get this in the right spot. You guys are developmental math 2. Okay, so today is Thursday, January 21st, 2021. So if you're watching this later on and you're like, wait a minute, those aren't the directions Mr. Shirley gave me, just realize this is from January 21st, 2021. But first off, let's talk about the test. So this class, the test is actually, it's probably open right now. If we go into Blackboard, I think I opened it this morning. I made it yesterday. Let me check real fast to make sure it popped up in here. Yep, test 2 is open. If you don't see it, let me know. But so test 2 is open. Remember, it's open till Sunday at midnight. So you have until Sunday at midnight to get the test done. It's the same directions as before. Once it opens, you have to complete it. You've got 75 minutes to complete you won't be able to see your answers until after, actually not, I think I put you view the answers not after the due date this time, but actually after the official due date. Because remember, I give you 2 days for students that are late to take a 20% cut. So it's actually after Tuesday, I believe, you'll be able to actually see what you got wrong. And I suggest you do that. That's the best way to study for the final. And when we get there, will be based on those your regular test. Okay, so and again, it's going to go over 4.1, which was the lecture from Tuesday that I missed, but it's in your Blackboard shell. 1.6, which we did yesterday, and 1.7, which we're about to do today, and 1.7. Oh, I think I called this lecture 1.6. I need to change that. 1.7, which we're about to do today, is actually pretty short, and so we should be able to get to a review for the test, which is what I'm hoping for. If we don't, that's fine. Just it'll be based on the homework, but we should be able to get to at least a short little review to kind of put everything together. Because remember, like I said yesterday, this test is like 2 topics that are completely different: solving systems of equations and exponential notation or exponential rules are just 2 kind of totally different concepts, but there's just no place to put them in the lecture. Okay, you guys that are in here, do you have any questions about that, about the test, about today? I'm gonna assume silence means no. Okay, let's get rock and rolling. So any questions about 1.6 or 4.1 before? No one's emailed me, so I assume we either haven't got to it yet or we understand what's going on. So let's look at 1.7. So 1.7 is a continuation of exponential rules or exponent rules. Let me switch over to my desktop camera. So it's a it's a continuation. Actually, there's only one more rule that your book goes over. So before we start going down this, I'm going to go over all the rules, and then I'm going to add the single rule that your book adds. Okay. So the first rule was the product rule. This is yesterday. Okay. This is 1.6 product rule, and it said I'm going to do just a quick example on the side. The product rule says, look, if we have x squared times x to the 5th, we just wind up with x to the 7th, right? And then we had the quotient rule that said, hey, if we divide exponents, let's say we had x to the 7th over x squared, we subtract 2 minus 7, or 7 minus 2 gives me x to the 5th. Now, these are really, really basic ones. And then we had the 0 exponent, which says, look, anything raised to the 0 power is just 1. And then we had the negative exponent rules. Now, there were 2 of these, really. The negative exponent rules that said, look, if we've got anything raised to the negative power, we have to make it positive by either putting it in the denominator, if it's already in the numerator, a negative, you put it in the denominator, Or if it's in the denominator and it's negative, you can bring it to the numerator, okay, and it turns positive. So these are kind of a vice versa type statement. But if it's negative in the numerator, pop it down, negative in the denominator, pop it up, okay? And then today, though, we're going to go over the power rules. So we're just going to start there. The power rule. Now, it's really one power rule, but you can kind of do this a few different ways, even in a basic manner. But it turns out if you have an exponential term, right, a to the m, and we raise it to a power, so we're raising it to a power, we just multiply the exponents. So a to the m times n, okay? So if you raise it, you're not raising m to the n power, you're actually going to be multiplying the m and the n together. So if we looked at a basic example, let's use these x's up here. We looked at a very basic example. If we have like x squared to the third power, okay? X squared to the third power, you would multiply the 2 and 3 because we're raising it to the third power. We're raising this exponent, I should say, to the third power. So it becomes 2 times 3. So x to the 6th, okay? Now, you got to be careful because it turns out with the power rule, if we have more than one term being multiplied inside, we have to make sure every exponent is raised to that power. So what I mean by that is if we have, let's say, a to the m times b to the n, and we raise it to the, I got to make up something, let's say y power, okay? Notice, look, major issue here is not issue, but major point of emphasis is that this has to be multiplication. If this was addition, we could not distribute the y, okay? We would have to like FOIL it out, multiply it out long ways. I'm going to show you that here in a minute. But because it's multiplication, the rule says, look, if you're multiplying, if it's just multiplying inside the parentheses and it's raised to a power, you have to distribute that y to both or all exponents. So this would become a to the m times y times b to the n times y, okay? A to the n times, so if we're multiplying on the inside, we got exponent, and then we're raising the entire term to a fraction. Everything, or to not a fraction, to an exponent. Everything in the inside has to be multiplied by that exponent. Gosh, every exponent on the inside has to be multiplied by it. I'm just rambling today. Okay, so let's look at, I'm going to expand this example a little bit. Let's say we've got 2x to the fourth times, or raised to the third power. 2x to the fourth raised to the third power. Now look, if we're going to do this example, we have to make sure that this 3 goes to each exponent. And remember, the 2 has an exponent of 1. This is why I'm bringing this up, because it's really common for students to just say, oh, that's 3 times 2, it's 6. No, we're raising the exponent of the 2, which is 1, to the 3. So therefore, we have to multiply that by 1 and 4. So we get 2 cubed times x to the 12th, right? 2 cubed times x. So, well, 2 cubed is just 8, so I'm going to write that up. 8x to the 12th power. Okay? 8x to the 12th power. Any questions about that before? Now, I'm going to start doing examples that bring in the rules from yesterday. And then we'll add another really power rule. Let's do a negative exponent power rule. So let's say we've got 3x to the negative 2 y squared, and I'm going to raise this to the negative 3, okay? So write that down, 3x to the negative 2 y squared raised to the negative 3. And again, all of these are being multiplied. Look, and up here, that was being multiplied as well. If it's addition, which I'm going to do here in a minute, I'm going to show you how different it is. But we're going to, now look, this negative 3 has to be raised to all the exponents. And again, this 3 has a positive 1 there. So I've got to make sure to distribute the negative 3 to all 3 exponents, okay? So I wind up with 1 times negative 3, that's a negative 3. Negative 2 times negative 3, so that's a positive 6, right? And then 2 times negative 3, well, that's going to be a negative 6, okay? Look, and we know from yesterday, we can't have a negative exponent to begin with. And oh, look, don't tell me 3 to the negative 3 is negative 9. Don't tell me it's negative 27. I'll get all that stuff first. You have to get rid of the negative and then do the actual exponential rule, okay, the 3 cubed. So let's get rid of the negatives first. The y and the 3 have to go to the denominator. X is going to stay put because it's a positive, okay? So then we get 3 cubed in the denominator, and we get y to the 6 in the denominator, right? It turns positive because we moved it down. Now we know 3 cubed. 3 times 3 is 9 times 3 is 27. And look, we don't have any repeating bases. We don't have any negative exponents. We made those positive. So we are done. Okay? Questions? I'll pause here for just a minute. I'm going to introduce a new rule. Do you guys have any questions? Okay, just pop it in the chat. And again, if you pop in the chat while I'm talking, you're not gonna hurt my feelings. Or if you butt in, you're not gonna hurt my feelings. Okay, so the next rule has to do with the quotient rule. It's very just similar to this. Look, if we have a fraction, let's say we've got 2 over y squared, and we raise an entire fraction to an exponent, we have to make sure that every term in the numerator and denominator is raised to that exponent. So again, this 2 is raised to the first power. So this winds up being 2 to the 4th, because 1 times 4. And the denominator is going to be 2 to the 8th. Or I'm sorry, y to the 8th, because it's 2 times 4. This becomes 2 to the 4th over y to the 8th. Okay? 2 to the 4th over y to the 8th. Check something real fast. I totally forgot to do. Yeah, no, we're good. Okay. And 2 to the 4th. Okay, let's do this. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So we wind up with 16 over y to the 8th. No negative exponents, right? We're good. No repeating bases. We're good there. And we're done. Okay. Okay, let's do one here that it maybe combines some negatives and exponentials. Now I want you to try this one. This is kind of a challenge one at this point. Okay, I want you to try this one. And again, there's going to be a few different ways to work it. Let's say we've got 3 x to the 0, y to the negative 2 over x to the 4th. And I'm going to raise this to the negative 2. So I want you to try this one. And I'm going to give you a minute. It's okay if you get it wrong. Just attempt it. Okay? Kind of see where you're at. Remember, it's got the power rule going on. So we need to make sure to bring the negative 2 into everything and then simplify it. Okay? I'll give you just a minute to get going on that. Zoom in here. Okay, let's do this. And if you're completely lost, that's fine. Just watch the expert in action. Okay. I shouldn't say that. What I like to do on these is actually bring the -2 into everything. So bring that exponent into every single exponent that we've got, okay? And then we wind up with 3, 1 times -2, that's -2, right? 0 times anything, 0. But you know what? That thing can just go away. Remember, anything raised to the 0 power is just 1. We don't have to write this. I mean, if you want to just exit out, that's fine. And then we get y to the positive 4. And then we would get x to the -8, right? So look, I'm going to do that. This x to the 0 is meaningless because it's just 1, okay? And I'm going to focus on the other 3 parts here. I've got to move this negative exponent to the denominator, and I've got to move this negative exponent to the numerator. So I'll do a little flipperooski here, okay? So we get x to the 8th, y to the 4th, right? Y to the 4th is going to stay put because it's positive. And then 3 negative to the -2, that becomes 3 squared on bottom. Well, we know 3 squared, that's just 9. So x to the 8th, y to the 4th over 9. And there's my answer. And actually, it's not, I mean, it's not really a solution. It's not a solution thing. We've just simplified these. This section is all about simplifying, right? We're starting with a single, kind of term, and we're simplifying it down. Okay, we're not solving for x or y. That's not what this section is about. It's really about simplifying exponents and really understanding all the exponential rules to simplify exponents. Okay. Okay. Oh, let me show you what I was talking about when you cannot do this, because it is a major issue that happens every single time in this class, okay? And not just this class, it just pops up where, look, okay, I'm going to go on my little rant here for a few minutes. I'm going to make you look at my face while I do this rant. Hold on. As humans, we have the most superior pattern recognition of all the animals, okay? And for now. Now, maybe science will find that that's not true with some other animal, but for now, we have found that we have the highest pattern recognition skills of any animal, okay? That's why we are at the top of the food chain and why we are here today, okay? I'm talking to you through the internet. Okay, so anyway, but with that comes the ability to be tricked, like a dog, right? I mean, if you, and I'm not trying to say we're dogs, but if you play catch with your dog, and then you take the tennis ball and you act like you throw it, right? And the dog runs after it, okay? The same thing can happen to us in mathematics. And what happens is it's when we see something that looks familiar and we want to do that because we think it's the same thing, because our brains are saying, hey, that looks the same. That pattern looks the same. We're going to work it the way we work this other thing, right? It's why, I mean, like trick plays in sports work all the time, right? And part of that is because the players have these pattern recognition skills and they're seeing the same play that maybe happens over and over again. And then boom, a trick play happens out of, maybe in football in the same formation or something like that. But it's because of these pattern recognition skills. And again, it can happen in mathematics. And I know students struggle a lot of times when it happens in math because you think you understand a concept, and you do understand a concept. You understand a certain concept. It's just that it looks very similar to another type of concept, okay? And it happens with these exponential, with the power rule. So I want to show you what I'm talking about, what I'm ranting about. And I promise I'm probably going to rant about that again, because I think a lot of times we get kind of down on ourselves for this stuff, but it's just part of the issue of being the best at pattern recognition, okay? So it happens when we have something that looks like this. Let's say we have x plus y squared raised to the second power. Let me do the focus here. X plus y squared equals the second power, or is raised to the second power. This does not fit any of the rules that we've gone over today because it has a plus sign, okay? We cannot bring this 2 to the x and to the y. This would not be simplified as x squared plus y to the fourth, okay? In our brains, it happens all the time. This is not equal to x squared plus y to the fourth, okay? And we can't do that. What we have to do, because it's a plus sign, we have to FOIL it out. Do you guys remember how to do this stuff? You'd have to multiply it out like this. I didn't mean to put that dot there. You'd have to do this and do, well, x times x, that's x squared. X times y squared, that's xy squared. Same thing on the middle, plus xy squared. And then lastly, y squared times y squared, well, that's y to the fourth, okay? We can add the middle two together. So we get x squared plus 2xy squared plus y to the fourth. Now, we're going to go over a review of this, I think it's next week. But I just want you to know, I want to show you that, look, because this plus sign's there, we can't distribute the two. And it really catches students every single semester. And if it doesn't catch them on the test, it'll catch you in the homework, and then you'll have to see what you did wrong, okay? Which hopefully catches you in the homework and not on the test. But look, guys, we cannot bring that 2 in because of the plus sign. Now look, so let's change it up in one little way. If it looks like this, and notice how similar these look, right? It's just the algebraic operation's different. This is what we've been doing today. This we can bring in, okay? So we've got x squared y to the fourth. That would be the multiplication there, okay? And this is the multiplication here. I want to go over that. So therefore, and I don't think you'll see this in the homework today. I don't think that's a thing, but it's going to happen throughout the semester, where you'll see more of this factored, little binomials. And your brain's going to go, ho, ho, Mr. Shirley went over how we can bring that 2 inside. Well, yeah, I did, but it had to be multiplication, not addition. Okay? Had to be multiplication, not addition. Any questions about this? Or comments? And typically you won't have a lot of questions until you get to this and you go, why is it not x squared plus y to the fourth? I know I'm doing this right. I quit. Let's steal some examples from the homework now from 1.7. Okay. And I'm skipping kind of the basic ones. I'm going to the harder ones. This is number 24. 24 says, this is on page 62 if you've got the book and you're following along. So page 62, number 24, 5x to the 7th, y to the 4th, over 10 x cubed, y to the negative 2, raised to the negative 3 power. And I chose this one specifically. I'm gonna do this one with you. I chose this one specifically because I want to show you kind of a different thing you can do before you get started. Okay. One of the ways of solving these is if they have a big fraction inside the parentheses, is you can simplify. Another killer. You can simplify this fraction first before you bring in the negative 3. Now, if you're like, I don't want to do that, Mr. Shirley, you can bring in the negative 3. That's fine. But I'll tell you, you can bring the negative 3 to all 6 parts here, right? 5 x to the 7th y to the 4th, 10 x cubed y to the negative 2. You can bring that in, and you can we'll get to the same answer, but you've got just a much higher chance of really kind of messing something up. I guess that's the best way to do it, making a goofy mistake. So I'm going to do that. I'm going to simplify this fraction in that green box, and then I'm going to bring the negative 3 in. So 5 over 10, that's just 1/2. So I'm going to just write a 2 down there. You can write the 1 if you want, but we don't have to. X to the 7th over x cubed. Well, I've got 7 on top and 3 on bottom. That's going to leave me with x to the 4th, right? Now, 4 minus a negative 2. Now, think about this. We can kind of do this on our head, especially if we did the homework yesterday. We bring this negative 2 to the top, it becomes y squared. So this would leave me with y to the 6th on top. Okay? Or if you think of it as 4 minus a negative 2, right? 4 plus 2. You wind up with y to the 6th. So look how much easier now it's going to be to bring in this negative 3 to all 3 of those parts, or only 3 parts. And they're a lot smaller. 10 to the negative 3, 5 to the negative 3, that would have been really kind of weird to work with, okay? So let's bring the -3 in now. We get x to the -12, right? Multiply. Y to the -18. And 2 to the -3. Okay, so in this one, everything's got to switch, right? The top goes to the bottom goes to the top, because we got two negatives up here and a negative down here. Everything's negative, all right? And so we got to move that around. So we're going to bring the 2 cubed up top, and then x to the 12th and y to the 18th on bottom, okay? And then 2 cubed, that's just 8. And then so we get x to the 12th, y to the 18th, and we're done, right? See if we got it right. Hey, I got it right. 8, and then x 12th, y the 18th. Okay, any questions about that? That's interesting. Questions. Okay, I'm going to skip around. Just butt in if you got a question. It's no big deal. Let's skip around to number 50 now. This is on the next page. Number 50, and it says 5x squared y to the 4th raised to the -2 times 3x to the 9th y to the 4th, right? Okay, now for this, this fraction, or this parentheses here is not raised to a power, so we're fine there. But this one is, it's raised to the -2. So if I was going to start this one, I would use really, still please excuse my dear Aunt Sally, I'm going to bring in the -2 to each one of these exponents. So I get 5 to the -2, x to the -4, y to the -8. Now, and then now I can drop the parentheses because it's all just being multiplied times 3, x to the 9th, y to the 4th. Okay, we got a lot going on here. This kind of feels more like a question from yesterday, right? Feels more like a question from yesterday. Okay, so now we've got to simplify this. Okay, look, we cannot multiply the 3 and the 5 to the -2 because this is an exponential term and this is an integer. And I don't think we kind of saw one like that last time in the last lecture, so I'm glad it got brought up here. So what I'm going to do now is I'm going to combine the like terms and then just simplify it, okay? These two are not like terms, 5, base 3, and we can't multiply them because it's a negative. So I'm going to combine the x to the -4 and the x to the -9. So I wind up with 5 to the -2 times 3 times x to the 5th, right? And then we've got y to the -8, y to the +4. So that would be y to the -4. Okay. Okay, so now I'm going to bring my negatives down and then simplify this out. So we have a 3 on top and x to the 5th. And then the denominator, I've got 5 squared now, right? Because it was negative, now it's positive. And then y to the +4. And I'm going to square out the 5. So we wind up with 3 x to the 5th, 25 y to the 4th. Hey, I think that's the answer. I'm going to check it. What number was this? 50? Yeah. Yes, it is. I've got the answers in the book. And they say I'm correct. Okay. Questions? Okay, I'm going to give you guys the homework, and then I'm going to pause this and start again. I'm going to try something. So, okay. So for homework, now this is section 1.7. It starts on page 62. And I need you to do 1 through let's do 1 through 51 odd. 1 through 51 odd. Okay. Okay, give me just 1 minute. I'm going to